we've got equations in the form ax plus b equals c. A, b, and c are integers such that 1 is the sum of the other two and a is non-zero. What are the possible integer values of x? So what solutions can we actually get? So when I did this question, I looked at three different cases. First of all, c is equal to a plus b. Okay, let's start with that one. Then we're going to get ax plus b is equal to a plus b, which is going to give ax equal to a. And because a is non-zero, we can divide through. The only solution if c is equal to a plus b is x equals 1. Right, case 2. What about b equals a plus c? Start with these two because they're going to be like similar, whereas the a one, because a is in front of the x, that looks a bit more complicated. So now we can write down that ax plus a plus c is equal to c. Cancel these out. So ax is going to equal minus a, and we just get one solution again, but this time it's x equals minus 1. Right, so only two solutions from these, but what about case 3? A equals b plus c. So now it's b plus c, x is equal, plus b is equal to c. So I can rearrange that. Let me do it bit by bit. B plus cx is going to equal c minus b. Therefore, x is equal to c minus b over b plus c. Now, it's not immediately obvious looking at this what x can equal, but there's a little trick you can do with these kind of fractions. I'm going to try to separate it out into like a number and then just a fraction by itself. And I also note that this bit here is a. I mean, I could have just divided through by a right from the start, but let's come back to that. Let's just recognize that. Right, what we can do is we can actually write it so that I have b plus c in the numerator. It's just to get b plus c, I'm going to have minus 2b here. So I'm just rearranging c minus b to b plus c, and then putting a minus 2b on the end. And I'll show you why that is useful, and it's useful in different areas in maths. I can now separate it into two fractions. So it's actually going to equal 1. This is just looking a little bit simpler because I've got a simpler fraction to look at. So it's still pretty complicated, I think. Like how do you know what solutions you're going to get? But there's a little trick you can now use, and that is to actually bring in a back into things. So remember, like they're all dependent on one another now. So C is not completely independent of B, for example, and because we've got B plus C equal to A, we can write it like this. Now remember, we could choose some values of A and hence some values of B and C, and that is the key to this question. If we let A equal 2, then X is going to equal 1 minus B. And remember, B is just an integer, so I can vary B now. And obviously C, like A is dependent on C and so on. It's not like C is completely independent, but it doesn't matter. I can now choose B to obtain all possible integer values for X. So e.g., I could let B equal minus 1. Then X would equal 1 minus minus 1, it would equal 2. I can get 2. In this case, I just have to think, remember, b plus c is equal to a, so c would equal 3 here to get me the 2. And I could, if I wanted x, so if want x equals 5, let b equal -4. So then c would equal, or remember, a is equal to 2, so I've got b plus c is 2, so c would equal 6. And overall, therefore, x can take any integer value. Kind of said it above, but I just wanted to conclude with that. So the first two cases didn't really yield that much. This third case is by far the trickiest. It's like realizing to do that, realizing that you can actually just set one of your A, B, or C equal to something to make life a bit simpler, which is what I did here. And then once we've got this x is equal to 1 minus b, realizing that we can vary b, then the answer comes out.